step into the captivating world of science and technology, where we unravel the mysteries of the universe and the wonders of innovation. Our channel is a beacon of knowledge, illuminating complex scientific concepts and making them engaging for all. We believe in the power of curiosity and the thrill of discovery. From the tiniest atom to the vastness of space, we journey together, exploring the limitless frontier of scientific knowledge. Today we delve into an exciting topic that has intrigued scientists and fiction writers alike: hyperjump and space travel. What is it about the concept of hyperjump that captures our collective imagination? Perhaps it's the allure of exploring the farthest reaches of the cosmos, or the thrill of outpacing light itself. Hyperjump, a term synonymous with science fiction, is the idea of instantaneously traversing immense distances in space, bypassing the constraints of time and speed. The origins of hyperjump can be traced back to the golden age of science fiction literature, where authors like Isaac Asimov and Robert Heinlein used it as a plot device to propel their characters across galaxies. It has since found its way into popular culture, featuring in blockbuster movies and TV shows, and has become a staple in the lexicon of futurism. But why has hyperjump become such a hot topic in scientific circles? It's the tantalizing prospect of overcoming the barriers of space travel. Imagine, if you will, stepping through a portal on Earth and emerging on a planet light years away, all in the blink of an eye. The implications are staggering, not just for exploration, but for our understanding of physics itself. Yet, with all its romanticism, hyperjump poses immense challenges. We're tied to the laws of physics which currently don't allow for such feats. The speed of light, the fabric of space-time, energy requirements, all these factors reign in our dreams of instantaneous cosmic travel. This idea of instantaneous travel across vast cosmic distances is fascinating, but is it feasible? That's what we're here to explore. To understand hyperjump, we must first grasp the fundamental principles of space and time. Now, think of space and time not as separate entities, but intertwined, forming a four-dimensional fabric known as space-time. This concept is at the heart of Einstein's theory of relativity, which forms the bedrock of our understanding of the universe. Now, picture space-time as a fabric. Objects with mass, like planets and stars, dent this fabric, creating what we call gravity. The heavier the object, the deeper the dent, the stronger the gravity. It's this dent, or curvature, that a spaceship would need to traverse in a hyperjump. But how does one cross such vast distances instantly? This is where wormholes come in. Imagine if you could fold that fabric of space-time, bringing two distant points together. A wormhole is essentially a theoretical tunnel with two ends, each at separate points in space-time. If we could create or find a wormhole, it might allow for shortcuts through space-time, enabling hyperjumps. But it's not all smooth sailing. Wormholes are incredibly unstable. Without a form of exotic matter to keep them open, they'd collapse faster than light could pass through. That's a significant challenge for our hyperjump ambitions. Now let's talk about the energy required. Even if we could stabilize a wormhole, the energy required to create one is astronomical, quite literally. Some estimates suggest it would need the energy equivalent to that of a star. And finally, the theory of relativity throws another spanner in the works. It tells us that as we approach the speed of light, time slows down. So, a journey that seems instantaneous to a space traveler could be years or even centuries in Earth time. So, armed with this understanding, where does that leave us on the possibility of hyperjump? In the quest to make hyperjump a reality, scientists around the world are pushing the boundaries of our understanding. Consider this. If we could bend space-time itself, we could potentially create a shortcut, a sort of cosmic bridge, that allows us to leap across vast distances in a single bound. This is the heart of hyperjump theory, and it's not as far-fetched as it sounds. Albert Einstein's theory of general relativity, over a century old, first proposed the idea of such a space-time curvature. But it's the 21st century scientists who are truly unearthing its potential. Dr. Kip Thorne, a renowned theoretical physicist, has been instrumental in developing the concept of wormholes, theoretical bridges through space-time, which could potentially facilitate hyperjump. His work suggests that with the right amount of negative energy or exotic matter, we could stabilize a wormhole long enough to allow for a spacecraft to pass through. It's mind-boggling, isn't it? Meanwhile, a team led by Dr. Sunny White at NASA's Johnson Space Center has been exploring a concept called the Alcubierre drive. This theoretical propulsion system would contract space-time in front of a spacecraft and expand it behind, allowing the craft to move faster than light within its own bubble of space-time. It's like moving the universe around you while you stay put. Over in Europe, the European Space Agency's Advanced Concepts team is investigating the feasibility of quantum teleportation for space travel. While still in the realm of quantum physics, the concept involves transferring the state of a particle from one location to another without physical travel. If scaled up, this could form the basis for hyperjump. And let's not forget the work being done at universities around the globe. From the University of Cambridge to the Massachusetts Institute of Technology, scientists are exploring the intricacies of space-time, wormholes, and quantum entanglement, all of which could play a crucial role in making hyperjump a reality. This is a field that's constantly evolving, with new ideas being proposed, tested, and refined. It's a thrilling time to be a part of this journey as we stand on the precipice of discoveries that could revolutionize how we travel through space. While we're not ready to jump across galaxies just yet, these advancements bring us one step closer to turning science fiction into science fact. The exploration of space is one of humanity's greatest endeavors, and hyperjump could revolutionize how we approach it. Imagine the ability to traverse vast cosmic distances in the blink of an eye. This is the promise of hyperjump, a concept that could fundamentally change our relationship with the cosmos. Hyperjump isn't just about getting from point A to point B faster. It's about redefining our understanding of distance and time. It's about making the universe smaller, more accessible, and ultimately, more familiar. Yet the potential implications of hyperjump for space travel are as vast as the cosmos itself. There are challenges to overcome, not least among them the sheer scale of the technology required, the energy needed, and the implications for human safety. But if we can meet these challenges, the possibilities are truly breathtaking. We could visit distant galaxies, witness the birth of stars, and perhaps even encounter other forms of life. We could gather data at an unprecedented scale, deepening our understanding of the universe's mysteries. The future of space travel is a thrilling frontier, and hyperjump could be the key that unlocks it. It's a bold vision, but one that scientists and researchers around the world are striving towards every day. In the vast expanse of the cosmos, hyperjump may very well be our ticket to the stars. The journey through the concept of hyperjump and space travel has been truly mesmerizing. We've delved into the allure of this fascinating concept, unraveling the mysteries that have captivated us for generations. We've dissected the science behind it, peering into the intricate mechanisms that might just make this fantastical idea a reality. We've navigated the latest research, exploring the groundbreaking work of today's leading scientists in the field. And we've contemplated the future, a future where space travel evolves beyond our wildest dreams. But the journey doesn't end here. We're just at the beginning of this cosmic adventure, with so much more to discover and understand. If you enjoyed this journey through the cosmos, make sure to like, share, and subscribe to our channel. Continue this exploration with us as we uncover more scientific wonders. Until next time, keep your curiosity alive and your mind open to the marvels of science and technology.